Hi everyone, in this video we will talk about energy levels. Earlier on we learned about the atomic models. We learned that we had a plum pudding model given by Thomson, and then we have a nuclear model given by Rutherford, and then Bohr was a scientist who gave us a planetary model where he said that there is a nucleus in the center and the electrons orbit around the sun, just like electrons orbit around the nucleus, just like planets orbit around the sun. So we call it a planetary model. And this path that is followed by the electron as it is orbiting around the nucleus, this path where electron is like revolving, is called orbit. An orbit that is close to the nucleus has less energy, and the one that's away from the nucleus has high energy. So since they have different energies, they're called energy levels. So the path around the nucleus where the electrons orbit, okay? So it's called energy level. So this is energy level 1, energy level 2, energy level 3. Now, how many energy levels any element has, it depends which period element is in. What that means is that elements in period 1, which is who is in period 1, hydrogen is in period 1. That means hydrogen has only one energy level. Okay, then who is in period 2? Lithium is in period 2, so lithium has two energy levels. Then who is in period 3? Sodium is in period 3, so sodium has three energy levels. Okay, 1, 2, 3. So this is how it goes. The period or row in the periodic table equals to the number of energy levels in the atom. So according to the Bohr model, it shows the electrons in their energy levels. How many electrons go to each level? It also decided by the Bohr. He explained it via principal quantum number. We use it principal quantum number. He used quantum numbers to explain this whole process. So he said that you have a nucleus here and it has energy levels around it. So let me draw four energy levels. So we have 1, 2, 3, and 4. Okay, these are orbiting around the nucleus. So how many electrons can go to the first energy level or two? Let's say I have 34 electrons in my hand. So how many electrons go to the first one, second one, third, or fourth one? He said we can calculate this by the formula 2n square, where n is the energy level. So this is n1, n2, n3, and n4. So n1, let's say I want to calculate the value for n1. So 2 times 1 square will be 2 times 1. So maximum electrons that I can put here is 2. And if I want to calculate it for second energy level, n equals to 2 right here. N equals to 2. So 2 times 2 square, which is equal to 4 times 2. So maximum electrons I can put in here is 8. And then third can take 18 and this can take 32. I know it says 8 here, but it can take 18. But what happens is we put 8, we jump up, we come back. So that's why it says 8 here. So I will explain that as we go further. So what I have said so far, that we have a nucleus and around the nucleus we have energy levels. And how many energy levels each element has, it depends which period it's in. So if it's in period 1, it has only 1, period 2, 3, and 4. So this element that I draw here, this element is in period 4 of the periodic table. Okay, this element is in because it has 4 energy levels. So according to Bohr, the maximum electrons I can put in here is 2, 8, 18, and 32. And also this energy level is called n. So this is n1, n2, n3, and 4. Okay, so this is what I have explained so far. Bohr explained it by principal quantum number. Okay, so the electrons in the outermost electrons are called valence electrons. So if any element has, let's say in a sodium has 2 electrons here, then sodium has 8 electrons here, and sodium has total of 11. So sodium has only 1 electron here. So the outermost energy level for sodium is called valence shell, and the electrons in that valence shell are called valence electrons. Okay, so keep it in mind. The electrons that are outermost, electrons in the outside energy level. So this, for this one, this is the outside. Let's say lithium. Lithium has one energy level that has two electrons, and then lithium has second energy level that has one electron. So for lithium, this is the valence shell because it's the outermost shell, and these are the valence electrons. So how many energy levels any element has, I told you it is decided by the period number. Okay, so if an element is in period, hold on. So let's look at the periodic table. So you have hydrogen right here. So hydrogen is period 1. Okay, it's a 1 energy level. Then you have lithium here. So lithium has how many? 2 energy levels. And then you have sodium here. So sodium has what? 3 energy levels. Then you have potassium here. So potassium will be how many? 1, 2, 3, and 4 energy levels. So how many energy levels? It is decided by the period number. And that also decides that, let's say for potassium, 1, 2, 3, 4. So this fourth one is the valence shell. That means I can calculate the valence shell by the period number. Okay, so I can calculate the valence shell, like how many valence shell, which one is the valence shell for any element, by the period number. And how many electrons it has in that energy level, the outermost energy level, are called valence electrons. And that information can be taken from the group number. Okay, the group number. So valence shell is by the period number and valence electrons are by the group number. So what does that mean? That if an element is in group 1, 2, then we have 3 to 12, and then I have 13, 14, 15, 16, 17, and 18. To calculate the valence electrons, we just go by the group number 1, 2, anybody here is 3, 4, 5, 6, 7, and 8. So this is how we do the valence electrons. So anyone in which group is called the valence electrons. So this information is about valence electrons. So let's do some example, like lithium right here. So lithium is in period 2. Okay, lithium is in period 2. That means the valence shell for lithium is 2, and lithium is in group 1. So valence electrons for lithium is 1. So let's talk about sodium. Sodium is in period 3. Okay, so for sodium, valence shell is 3 and it's in group 1, so valence electrons is 1. Everybody in group 1 has 1 valence electron, 2 has 2 valence electrons. So let's do some practice on this. So carbon is in period 14. So if you look at the carbon is sitting somewhere here. This is 13, this is 14. So this is where carbon is sitting. So carbon is in period 2. Okay, so carbon is in period 2. That means it has 2 energy levels around it. It has total of 6 electrons. Okay, out of the 6 electrons, 2 are here and 4 are here. So valence electrons are 4 because carbon is in group 14. So valence electrons are 4. The energy levels are 2, 1 and 2. And valence shell is also 2. So valence shell comes from the period number. Okay, and valence electrons come from the group number. So this information is coming from the group number. This information is coming from the period number. Okay, this is the same information for the energy levels as well. So go ahead, let's do silicon. So silicon I know has 14 electrons. Okay, so silicon is in period 3. So 2, 8, and 4. This is how you do it, because according to it goes 2 here, 8 here, and 4 here. So how many valence energy levels? Energy level, as you see, 1, 2, 3. Okay, valence electrons are right here, 4. Silicon is also sitting here, so it's group 4. Okay, and valence shell, this is the outermost shell, so it is 3. So this is how you need to do this table. So go ahead and complete this chart, complete this table, and then we move forward. So valence electrons are electrons in the atom's outermost energy level. Okay, and I will explain that next hold on a second, I'll do it in other video. So let's complete the energy levels here and complete this page. Thanks.